Yeah, so guys, my name is Siddharth. I am in the analytics Vidhya as a in a data science team. So I'm gonna give you a brief introduction to the data sessions. So basically, the data session is a series of webinars conducted by Analytics Vidhya and led by top industry experts. And it is a fun way to understand the concepts of data science from the leading players in the data tech domain. So, as the name suggests, it's 1 hour dedicated to data. So, we are hopeful that these sessions are going to be great source of enrichment and value adding for community members. So, now coming to our session today, which is customizing large language models GPT-3 for real life use cases. So, in this data, Anustup will cover all about LLM, starting from defining fundamental definitions of LLM and highlighting important mathematical understanding to explain real life examples. So he will also explain the real life project based on customizing GPT-3, learning path for LLM models, and finally, how you can kickstart your career in AI. So before we kick things off, I hand it over to a speaker, a quick recap of the housekeeping items. Yeah, so we are recording the session and we'll make the recording available in a few days on our YouTube channel. And please use the Q&A section for asking any question you might have during the session. And we will do our best to answer them as the data progresses or towards the end. Also, we will share a poll about feedback of the session towards the end of the session, which I request you all to kindly fill up. So now coming to our speaker in this session of data, we have Anustup Mukherjee with us. So guys, Anustup Mukherjee is presently, yeah, hello.
Sure. Go ahead. I just lost my internet connection. Yeah.
Okay, no problem. Yeah, so guys, Anustup Mukherjee is presently working as an AI engineer at Newton School, building the next edtech revolution with power of AI. So former to this, he was an intern at Samsung, Google TensorFlow, WRI IIT Patna, and IIT Bombay. He has 10 plus years of experience of working with companies of India and Silicon Valley to develop AI solutions. He has also worked with MHRD India. He is a presidential award winner for AI contributions toward a national building. So now over to you, Anustup. The virtual stage is all yours.
Yeah. Thank you so much. Thank you so much, guys, for the warm introduction. And hope everyone can hear me out properly. And yeah. So, okay.
Yeah, you're audible.
Thank you so much. So let's get kick started with today's session. So today's session is all about the most biggest trend in the industry right now. It's all about GPT-3. And obviously, as the name comes up with GPT-3 is something like as an open AI, what kind of revolutions they are doing, and how the GPT-3 actually works on the back end with the from the mathematical point of understanding as well as the point of understanding of artificial intelligence, and why it is called as the next revolution means like why everyone is telling the GPT-3 is going to revolutionize the world, it's going to change the world, and even some kind of the faithful stuffs as well. So today we'll discuss on all these things, and also I will be showing you guys some kind of the practical applications that I am doing with GPT-3 right now, and some of the experimentations that other peeps are doing in the world. As well, I will be also speaking how you can customize your GPT-3 models or any GPT-3 application or any kind of architecture that is related to GPT-3 for your own use cases. Okay. So without wasting any time, yeah, sure. So without wasting any time, just let me share your screen. Just give me a confirmation once you can see it. Okay. So I guess you guys can see my screen. Just can you give a quick confirmation on the chat? Okay. Cool. I guess my screen is visible to everyone. Cool. So okay. So without wasting any time, so let us get started with the GPT-3 and what does this GPT-3 is all about and what
Anustup,
does it?
sorry to
Yeah,
hello.
sure.
Yeah,
It's showing.
sorry to cut you in between. Actually, your screen is not visible.
Okay, just a second. I'm resharing it out. Uh, okay. I guess better now.
No, actually, there's an it is coming. Anustup Mukherjee has started sharing screen, and the black screen is coming over there. Like the
Just a second. Guess there is some sort of glitch. Okay. Second. screen. Can everyone see it now?
Yeah, it's visible now. Yeah.
Okay. So there is some sort of glitch from the Zoom side. Right? Cool. So let us get kick-started. Yeah. So let us get kick-started with the concepts of the GPT-3 and what does this term actually means all about, right? So when we speak about GPT-3, so basically it is nothing but a transformer with a huge scale. So now I will not tell about a lot of big terms or big concepts so that it can easily, everyone can get easy context of it. So what does this happens is whenever we train out an AI engine, a AI engine always gets trained with some sort of data, right? And it's a general hypothesis. The more amount of the data you feed to a model and more good amount of the processing you do with with that type of a data, you will be getting a better features to get kickstarted with a better algorithm results, right? So it's all the game about data and the logics and the feature engineering we used to do on the end of the models, right? So basically, GPT-3 also comes up with this kind of concept. Though it is not the first model that these peeps are introduced. I will be also telling who introduced it and what is the history behind it. So there are various variations and various sort of experimentations that is being carried out over 5 to 6 years from now, right? So basically, the start was very simple. The simple start was when the engineers and the researchers were getting stuck up with the results of the neural networks. Means like every neural network has some kind of a threshold factor. When you speak about a neural network, yes, we can solve multiple problems by using a power of neural network, from classification to some sort of predictive analysis to some sort of solving a detection problem. Neural networks played a very good well, right? But there is always a biasness factors with the neural networks because whenever an AI model predicts, the AI model predicts with some sort of probability. At the end of the day, the prediction turns into some sort of probability. The AI gets a level of confidence when it is predicting something, and when the confidence is handsome enough, it gets predicted out. Okay, I can predict it in this way. Okay, so what is the major problem with the neural network game was any kind of neural network architectures. I'm not specifying with either a convolutional architecture or a residual architecture. I'm just telling the family to be a family of the neural networks. The GPT-3 is also a type, but it's called as a modified type of it, right? So what happens with in general neural networks is there is a high factor of biasness. Means like when there are complex features, means like suppose think like you have to do a very finite level of analysis in between two objects. Means like there is a square of somewhat bigger shape and there is another square with having a shape suppose 2x or only 1x smaller than that of the bigger one, right? Understand they have same colored, same dimensions, or might be same sort of orientations, their placements, everything is same. And now you're telling the neural network, can you tell me, is there two square or is there two different square or is there is a single square, right? So here your neural network will be getting stuck up because there comes a biasness factor, right? So what does this biasness factor is? When the two distinguishable features or the discriminative features doesn't have a lot of difference in between themselves, the neural network gets stuck up and the biasness factors get increased. Okay. So this is one of the factors that the researchers had been pointed out, and this led to a part of the big models or the larger models. So here comes a hypothesis. Again, this hypothesis is very famous in our world of artificial intelligence that is called Moravex Paradox, or someone called as, or there are several other paradoxes. So what does this Moravex Paradox speak is a AI model can perform highly well if you are trying to solve a complex problem, and while you come to an easier problem, it gets stuck off, right? So basically, the researchers told that if I make the neural network so robust, suppose think a scenario, your neural network have a data of all around the world, right? Means like whatever data is present over the internet, obviously, your neural network have that data. And your neural network is actually just like a human brain. It have a very good capability of understanding every end of a single feature, right? Then what is the case on that particular thing? Then obviously your neural network is the best neural network. Means like it can have the human like power to analyze everything. Okay. So I guess there is some kind of issues with my voice. Okay, some people
No,
have
I'm getting your voice.
your
Like it isn't updated.
okay.
It is
Okay,
coming
so
just
just a
fine.
sec. Okay, it's fine. Okay, cool, cool. So I guess it might be breaking for someone and might be breaking not for
I guess
all.
the
I
internet
don't know.
connection is not up to the par. There is some problem. Yeah, you can
Okay, okay,
continue.
okay, cool. Thank you so much. So okay, so so let's get back to the discussion. Okay, so this was the very basic case of the how the researchers were trying to come out of this neural network architecture. So on that time, we had already played the game of this kind of attention and the transformers architecture. So on a very basic scale, when you are having a bunch of multiple features to get processed or get engineered in a case of a neural network, each and every single features needs a kind of a special attention or special type of engineering so that you can have a discriminative value in between themselves. Okay, so that is a complete different discussion of about how the birth of transformers and attentions takes place. So right now, I am not going into that kind of discussion. So let us understand the most advanced versions of these architectures were there in the field. So what these researchers at OpenAI did at the OpenAI labs is they first tried to make the neural network so robust by playing with a larger amount of a data. So obviously, if you speak about a large amount of the data, then that doesn't mean it's all about collecting the data. It also includes annotations. Okay. So they had specified their every simple use cases. So this was the birth of the large language models. So this LLMs is all about they have a huge database of each and every text queries or any kind of a voice-based queries or any kind of the Google search queries that general peeps used to do. And obviously it is an openly available data set. There is no kind of the breaches, no kind of the copyrights to collect that data and everything. So they have, you might think about a scenario, this kind of models have that much of data that is actually present in an internet, right? So now comes the twist. Okay, I have that much of data, then what to do with this data, right? So they had actually manually annotated all kind of this data for specific use cases. If you say about classification, yes, they had annotated. If you say about detections, yes, they have annotated all kind of the text data. Now I will be telling you about the games of this GPT-3 architecture. So many of you who had already used OpenAI Codex or who had already used with this GPT-3, you guys might say, hey, you are telling obviously in the OpenAI playground, there are some mentioned use cases, might be code completion, might be code translation, or might be transforming code from one programming language to another. But if I give an unknown use case to that language model or GPT-3 can equally perform well. Now you are telling the data is annotated, then how can it perform in that unseen or unknown use case? So I will be coming how this architecture is used to perform on that particular section in the later half of this talk. So GPT-3 again, GPT-3 is nothing but a modified transformer architecture, right? So it is so robust that is having a huge lot of databases, more than 780 million parameters that we tell as the 780 million features are getting processed to train GPT-3 till that, though it is every day modifying itself because the type of a AI that GPT-3 is dealing with, it is called as the adaptive AI. Now, many of you might think, what do you mean by adaptive AI? So adaptive AI is something like it generally happens in our daily life. Suppose you are a student and you just appeared for an examination, and in an examination you had solved two questions and two questions you cannot solve. Then obviously, like I don't have a proper knowledge with these two questions. So think about a scenario, either you have solved the two questions or you have solved the two questions but the solution was wrong or you cannot solve. So your brain tell, okay, I will go back to my home after this examination, and what I will do is I will again thoroughly revise this concept and making it correct, right? So see, the use case is so specific. You know your error. So this is my error point. I am specifically rectifying my error, right? So this is what the adaptive AI is called. Adaptive AI means the AI every day understands what is my false negatives, what is my false positives, and where is the problem. And it is actually continuously learning on that false parameters to improve itself every day. So OpenAI is playing in this domain of the adaptive AI. So yes, it is called as, which is also you can tell as mostly modified self-learning AI as well. And this is actually what the future is speaking, right? AI model can understand its error by its own. So this is one of the flavors of GPT-3. Okay. So again, GPT-3 is a robust base of this kind of transformer architecture. Okay. So cool. So when OpenAI tried to play with this kind of GPT-3 architecture, So one of the common thing that they've identified is called as the text generation. So now I will be coming to this section of an NLP. So this domain of the NLP is very interesting because whenever we speak about NLP, it's all about text and the verb, text and the audios, right? So it is literally very difficult to globalize this domain, right? So literally NLP have several kind of subdomains. Like you can do text classification. That examples like sentiment analysis, blah blah blah, is actually present in the market for a longer time. You can do detection as well, right? Like this sentiment analysis problem can be solved by this both type of a thing, by classification or detection, anywhere like this. But yes, you can solve it like detection domain, classification domain. So there are some kind of this type of applications as well. Storytelling by AI means like you are given a prompt to AI model, and AI model is writing the next lines. Okay, so this is called as a generative AI. Okay, so GPT-3 globalized this entire thing within a single domain that is called text generation. So text. So you might say like, okay, I can understand this. The use case that you told right now is storytelling AI. Means like you are telling the AI, hey, give me a nighttime story. So AI is giving you a nighttime story. Or if you are given a prompt, Ram and Sham was playing football. Dot 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 dot. Please AI complete my story. So AI can generate. So this is all about generative AI, generating text. Okay. So this makes sense if I say about text generation. Now you might come up with a use case. So how can you tell if I give AI a sentence? Suppose, hey, you can't do nothing in life, and I give this sentence to AI and I ask AI what kind of sentiment this sentence is having. How can you fit this into a text generation algorithm, or how can you tell it? This is obviously either a classification or detection domain problem, right? So how can you tell what you are generating over here? So yes, this can be equally fitted to a text generation algorithm. So if you see about a sequence, like suppose you understand this entire text to be a sequence, a mathematical sequence. So entire text is actually visualized by an AI model by a mathematical sequence or a series, right? A lot of series through which we used to deal with this. There are several type of a series of tokens. Okay. So every text is being comprised with some sort of tokens or values, and that tokens is actually being arranged or organized in a form of a series. There are multiple type of a series in mathematics or in AI, Hamilton series, Taylor series, blah blah blah. I'm not going to that kind of deeper mathematics, but yeah, a series is formed by that particular tokens or even the vector values, right? So again, so what you are doing, so your input is a series and you're generating output, which is also a series of values or token, right? So what does the model is doing? Model is understanding one series and giving in an output another series. So you will be telling, so another series means if I tell you a sentence like you can't do anything in life. So this is a series of tokens or series of vectors. Like, so series means, suppose if you consider as each and every single character to be a mathematical figure, so it is coming into a series. So it is having a series of input. So AI is processing this input, and in return, it is what it is giving is another series of value or series of characters. So the entire globalization is being done is like the basic hypothesis behind this text generation algorithm is treat every single input or every single text as the series of the vectors or the series of the tokens. So GPT-3 works in the tokens mostly. So series of the tokens so that you can easily fit any and every problem statement robustly within a single algorithm. I guess it makes sense. So if you guys have any doubt, you can ask in the mid of the session, or I will address every doubts at the end of the session as well. So in this way, GPT-3 and this OpenAI pips had globalized this entire NLP industry into one single problem statement, that is a text generation. They had played only on the series game of the features. Okay. So before coming into that kind of architecture level understanding, see, because it is like a little bit boring to some people or interesting to some people, debatable point. So let us see what are the present use cases of the GPT-3 and how the evolution took place. So right now, the most used use cases of the GPT-3 is translation of the code, that is called as the code automation. So this OpenAI GPT-3 is so much powerful that it can write code for you. That means you are given a problem statement. So what happens is, suppose you are a competitive programmer and you are solving a problem at Code Forces or Lead Code or Geeks for Geeks, any places. So specifically, I will tell for Lead Code because I had the amount of experiments that I had did with the GPT-3 and I had interacted with the folks and everyone, it can easily solve each and every lead code question. Hardly there might be one or two question it cannot solve, right? Hardly. because I mostly feel that is mostly trained on the lead code submissions and the solutions. So it's my observation. I don't know. Okay. So what you can do is, so you can give a problem to GPT-3 to solve. It might be a lead code problem. It might be a gigs for gigs problem. It might be a code forces A, B, or C problem. Though it fails in the D problem. Code forces C and D is the ambiguous case for GPT-3 right now. It will exactly write a code for you. It will solve the problem for you, and you can easily copy and paste it to that particular playground, and your test cases will be getting passed. So that's the game. So writing of the code, the biggest examples you can see is GitHub Copilot. Every one of us know, right? So another flavors of the code automation that GPT-3 had added is translation of the code. A common problem in a developer or a programmer's life is, like, I will say, like, suppose you are a Python programmer, but for your company you have to write some code in Haskell or Go, right? Or might be in Scala or Perl. Like, for the Perl, I must say, in my last company, I was a dedicated Python programmer, though I play with R and MATLAB as well. But I am not so much scalable with this kind of Ruby and Perl. Okay. So because we generally don't use this a lot for a deep level of machine learning, but they had some kind of specific use cases. So either to learn that programming language from scratch, so GPT-3 will transform your entire code, right? That means write your code in Python, send this code to GPT-3. GPT-3 will be transforming that code into any language you want, any language. So that is the code transformation. Okay, I will be also giving you some sort of real-time demos in this session. So another big examples that the GPT-3 had achieved is, apart from code translation, is explanation of a code. Most of the times, so basically most of the times what it happens is, we the developers or even programmers used to look after a lot of code in the market. That means, suppose I have to make an app and I'm looking for someone else code. Most of the times I can't able to understand what the person had written, because every code is not a production ready code. It have a lot of assumptions, might be the variable declarations are not in a proper format. So the code is not readable. So what GPT-3 will help you, just paste that code in GPT-3 and it will be explaining the entire code in any language you want. You might want explanation in English, it will be explaining in a natural human level English. If you want to be if you want it to be understood in Japanese, it will be giving you an explanation in Japanese, Chinese, even in my mother tongue Bengali, it can generate you out. So this is the power of code explanations. So some other explanations or some other amazing things that I had personally achieved, or my company had personally achieved with the power of GPT-3, that is Newton School. Newton School is also playing an amazing game by using the power of GPT-3 and this kind of the open AI. So the major problem with the noob level programmers is they can't able to understand what is the time and space complexity, right, of your code. Because at initial days, every programmer struggles out with this. So we automated this process by the help of GPT-3 at Newton School. So Newton School revolutionized this process. Like, write your code, whatever code you want, and just send to us. So our GPT-3 algorithm, what it will do is, it will tell that, see, this is your time and space complexity, and this is actual time and space complexity. So, and this is the way you can modify your time and space complexities of your particular code that you have specifically written. So it will help a new level programmer to a very quick guide to modify or give an optimal solution of his or her code. Another things, like, we were able to generate hints for any programming problems. That means whatever programming problems you can come up with, and we'll be giving you some kind of subjective hints to you. That means, hey, you can go with this kind of, so you can go with this kind of recursive power, like a recursive algorithm, or you might use hash maps and something like this. Okay. So this is all about the code automation. So what other things that OpenAI peeps had been achieved of is something like, you can have a conversation with GPT-3. So ultimately, lonely people have someone AI peeps to be interact with. So GPT-3 can talk with you. GPT-3 can take your interview, or you can be an interviewer, and GPT-3 can answer your questions. So we are also revolutionizing this doubt solving by customizing the GPT-3 for our use cases at Newton School. Means, like, any subjective doubts or any kind of theoretical or conceptual doubts can be solved by the power of GPT-3. Suppose you came with a question, I can't able to understand this particular function in merge sort. You ask this question to GPT-3, it will be answering your question easily within some seconds. Okay. So this is called as conversation AI that GPT-3 had modified and revolutionized. GPT-3 can write poetry, GPT-3 can write stories, GPT-3 can generate artificial voices, GPT-3 can generate artificial music, songs for you. So just type the query, generate this song for me by the power of AI. GPT-3 will be generating you out. Even GPT-3, right now, some common examples, I can see some of the researchers at Hugging Face, I don't know, I can't recall, from Russia or Italy, I can't able to understand right now. So they guys had generated a complete script, a movie script by GPT-3. They just written a prompt to GPT-3, hey, we want to direct a movie. The basic outline plan is this. Can you just write a complete script for this? The GPT-3 had written a complete script for that particular movie. Okay. So that movie is also equally available on YouTube. Anyone can go and check it out. Okay. So the amazing other kind of an observations that the GPT-3 had been achieved is apart from this question answering, conversation, generation, the GPT-3 can able to generate your designs for you. Like it had also there is a tool available at Figma or Adobe XD called as Anima. Anima is also using GPT-3. Being a designer, just go and write a prompt. Hey, I want this and this and this design. It can generate that kind of particular designs for you. It can it can generate a mockups just by simple prompt. So it is trying to make life so easy. Just you know English, go to GPT-3, write the prompt, it will be getting generated everything. These are the common industry level examples that peeps are doing, we are doing by the power of GPT-3. Cool. So let's get started with the next part of this session. So how now let us understand how this GPT-3 works and how you can customize your GPT-3 model or algorithm, right? So okay, so generally, when this GPT-3 got this bird, so GPT-3 is not the first thing that this OpenAI peeps is doing. So I will say, I guess every one of you know about DALI 2 engine, right? So DALI 2 is a famous image generation engine right now. Though it have a lot of competitors right now, Google had launched its own and several other peeps had launched their own and own. But DALI 2 is the first version of the revolution. I'm just giving you the history of DALI 2. So the father of DALI 2, the person who made DALI 2 is Paul Boris. The Paul Boris is actually doing this experiment since last 9 to 10 years. There is a platform called as crayon.com, right? It is also available right now in Google. So Crayon was the first platform made by the Paul Boris some years back. And from that time, he's collecting the data to make the most advanced image generation engine at this era, right? The same thing goes for GPT-3. GPT-3 have the previous versions of General GPT, GPT-J, GPT-Neo, GPT-2, several other variations as well. These are the most common variations, GPT-J, Neo, and GPT-2. So these all were the common experiments that these peeps ran in the market for the longer amount of time, and they had collected a huge sort of the database, and then they were able to make this much of a robust engine. So on a very basic understanding, it's nothing but a common crawl from all over internet. And if you tell me what is GPT-3, it is the most advanced search engine. If you tell GPT-3 go and print a code from lead code for this particular problem, it will be directly exactly printing that code for you. So it is the most advanced search engine you might tell. Okay. So this is how the data collection stuff happened for the GPT-3 and something like this. Okay. So we're done with this data collection architecture. So there are several other alternatives of the GPT-3 is also coming in the market just for your food for your interest. So since OpenAI Codex or OpenAI GPT-3 is paid, or you might need some sort of special accesses to access it for free for 1 year. So this open source peeps like Hugging Face Transformers and this kind of people is also making alternatives of GPT-3. There is one of the another alternative that is being made by Hugging Face peeps. So that is also a type of a GPT-3 that is called Bloom's engine. So Bloom's engine is also a LLM, but it is free to use. Any one of you can use it, and this also have same kind of applications that GPT-3 used to provide. That is the code automation and something like this. So the results are not so much impressive like the GPT-3 by OpenAI, but yes. So, but it is also equally good. Like we can give it a scale to that. And apart from this, Facebook have a very old experiment with this GPT-3 called as OPT engines. So OPT, but it still can't able to achieve a lot of SOTA. Even the peeps from IBM they did a lot of experiments before this birth of this GPT-3, something called as the code parrot or CodeNet experiments by IBM. So they had also did this kind of things for code automation, but they were also not able to be successful. The major reason is the architecture. So the architecture that the OpenAI peeps had written is the most advanced thing that revolutionized everything. So let us understand the architecture that the GPT-3 is following. Okay. So yes, so some people have a big debate over here. So why GPT-3 is search engine or not a search engine? Yes, obviously GPT-3 is not a search engine, but I will tell why you can make a hypothesis accordingly. By the end of the session, I will be specifically addressing these doubts. Why you can give a hypothesis of a search engine to GPT-3. I will show some kind of use cases to you guys. Okay. So okay, so I'm just taking example from someone's talk over here because to explain the architecture stuff. So this is a PPT from one of the Stanford researcher. So I'm just taking it out to just understand some sort of mathematical concepts and why these LLMs are so robust and why these LLMs are revolutionized everything. They had side back the other architecture called as the OPT, Blooms, and like this. Okay. So what is the game that these peeps used to play in this architecture? That means is they have a huge probabilistic difference for each and every feature. So what does this probabilistic difference means is all about. So what happens? So suppose you're a human. So you're speaking a sentence to someone, right? So that means I'm right at this particular time. I'm just giving this session to you peeps. Okay. So in this session, I'm telling every sentence by some sort of thinking that today I cannot tell you without a think, without a thought. I cannot tell you a jargon that you guys can't able to understand. So we humans, whenever we speak a word, we think about what to speak and what not to speak. Okay. So till that AI had this power, but only AI used to control this power with some sort of the threshold values or some sort of the probabilistic values only, nothing else. Right. So the first level game or first level pivot that GPT-3 did on this is used to assign probabilistic score for each and every word, or it's not even a word, each and every token that GPT-3 predicts out. Okay. So means like it have a general inference of what he had already spoken, what the user had already spoken. That means GPT-3 always needs an input prompt. Okay. So what does this do from an input prompt? It actually understands the entire context of what the user is wanting, what is the basic or background context behind that. Based on it, it assigns some sort of probabilistic matrices or some sort of probabilistic weights to each and every values of the prediction. Okay. So for that reason, GPT-3 doesn't predict something that is not related to the central context. So many of you might be thinking like how it gets context of this kind of things or what you understand by the context. So it's all the context stuff is all about. I'm not going to going deeper mathematical concepts of it. I'm just giving some kind of basic ideologies of it. The context game, how this kind of the basic AI architecture generates a context is entire thing is a mathematical matrix at the back end of a AI model. And every mathematical matrix have some kind of a central pivoted value. If you come from a statistical background, you can understand. You can have a data central tendency. You can play with the data variance game. You can have the data central weight theorems. So basically, every data have their central point values, and that central point values actually have some kind of a unique figures, and that unique figures or that unique matrix representations is to tell what the data is all about. Okay. So from that particular unique numerical values or numerical factors, easily it is considered to be as one of the context vector. So we assign the probability. Now here the probabilistic thing is not about a coming from simple Bayes theorem. It is coming from some kind of conditional probabilistic logic. So basically why it is called conditional probability, because the conditional probability gives you a very good elaborative context at which weight matrices to take, which context vectors to take and which not to take, so that you can twist your probability according to your predictions. So on a very level of a very layman's language, it assigns probabilistic score for each and every prediction, so that which is completely related to your context, so that any value that is being predicted by GPT-3 is not coming into some kind of false positive. Okay. So cool. So this is a very basic ideology of the probabilistic game of the GPT-3 and how this architecture is to working on. So now come, let us see the neural network architecture of this particular GPT-3 engine. So what does this GPT-3 used to do is GPT-3 used to do a lot of Yes, George. I had seen one of the chat. Someone had told Google actually has the same kind of a model closest or superior. Yes, you are absolutely correct. I'm just giving you some kind of my experience at Google there. So yes, Google have more and more advanced architecture to than that of these GPT-3 engines. And even since they within a day they had made an alternative to DALI, but there are also some features which are so let us get back to the talk. Okay, so let us see the neural network architecture of the. Uh, so let us get back to the neural network architecture of this GPT-3 engine. So if you see this architecture, those peeps who had already into AI and already have seen some sort of this transformer architecture. So this type of a building is not so much new to you peeps. But yes, so where is the twist is? The twist is all about into the transformer block or in the transformer architecture. So what is the game? What is the game it actually plays at the back end of it? It takes the context vectors of each and every inputs or each and every data you had passed to this particular model, and it do not a bulk processing at a single amount of the time. That means, so what do you mean by a bulk processing is whenever you play about the trivial neural network architectures, like if you say about a trivial CNN architecture or trivial ResNet 101 architectures. So in this architecture, what happens in general is you mostly the engineers focus on getting more and more contexted features or that kind of the features that is actually useful for the computation. But you got the bulk of the features. Now how will you do that kind of feature learning thing? So this GPT-3 peeps had mostly considered this kind of place. So basically they are not doing a bulk processing of that particular pool of the features. So I might tell you mathematically. So there is one of the concept of centroids and logics by Frederick Eric. Anyone can find it out over Google. The concept of the centroids and logics by Frederick Eric usually speaks out is something like you guys have a pool of the matrix values or some kind of a huge matrix features or x amount of suppose x or n amount of the matrix features. So if you consider the entire structure to be a centroid or a hollow centroid structure, so basically you might think like suppose or just understand like you have n number of values and you are trying to align these particular values within a structure, then obviously some value will be at a central point and some value will be very far away of it. Okay, so basically if you try to trace out one value to another value, or suppose you are trying to calculate any kind of distance between the values to have some sort of context about the orientations, that will be a big anomaly because you can't able to try properly pivot a lot of features within a single time. Which feature is important, which feature needs to be first processed, which feature needs to be last processed, or which feature plays an important role wise prediction, which is not playing an important role wise prediction, right? So in generally if you see a matrix level understanding of a neural net, and generally our trivial neural networks always make a structure at inside to that particular inside the computation. So what does this compute? There are several kind of structure models is being proposed by a lot of mathematicians. I'm not going into the structure models, but the famous structure models that we always call as a circular structure or something called as a centroid or holoid centroid structure, something like this. But in every case, some features are always coming out of this neural network computation by some sort of dropouts and every kind of thing. That might be an important feature. So GPT-3 said like, okay, in this architecture, we are ready to increase the blocks of the processing, but we are not ready to lose our features. We can't able to understand which one is important or not. So basically, they made a L cross 12 repetitive blocks of the transformer network. Means like it have, suppose you can tell N cross 12 amount of the transformer blocks. In each transformer blocks, the features are getting prioritized. Means like the first set of the features that is the highest priority feature, so they used to also maintain some sort of a priority queue. You guys might be curious how they maintain a priority queue. These priority queues are being maintained again by calculating the numerical values of each and every features, and that numerical values are coming from a logic of something called as the Laplace coefficient. So this Laplace coefficient used to tell like the matrix values which is having the highest weight should always have the highest priority. If you read the actual research paper of the GPT-3, you will be having a proper understanding of this Laplace coefficient, Laplace coefficient. So I'm not going into that kind of deeper understanding, but simply you are maintaining a priority queue, and in that priority queue, the first prioritized features will come first and getting processed individually in each transformer block, then the second, then the third, so that the model have a proper level sensitive understanding for each and every architectures. Okay, so this is how, where is the twist is playing in the GPT-3 architectures. Okay, so I had already explained about what is the difference in between a CNN architecture and in general a GPT-3 block. A CNN is a straightforward block with a single block game. It have the multiple transformer blocks playing with it. So the last but not the least important twist that the GPT-3 have is called as the masked self-attention. So there are every one of you, those who are, I guess, since many of the peeps are already understanding this session, so I guess everyone is familiar with this attention networks. So attention architectures or self-attention architectures is being already common into the market. It's not a very new thing, but there is something called as the masked self-attention. So what is the masked self-attention is making the GPT-3 a robust model. So what does this mean? Like suppose your model is, again, when the model is completely trained, now it is having a complete pool of features. Okay, so that particular pool of features have several kind of features. Means like a set of it might having a feature set for classification specifically, a set of it for generation specifically, or set of it for any other task. So if you are giving a query, transform my code, which feature to selected or which feature not to be selected, or which pool to be calculated or which pool not to be calculated. So this game is being handled by the masked self-attention. I'm not going into so much deep of it due to we have only a very less amount of the time, and I have to show you some sort of demos as well. So cool. So okay, so cool. Cool. So now coming to the next part of this talk. So I had already explained what are the several kind of the things that the unique things that the GPT-3 architecture is having inside it, and also a general GPT. So since they are the few short learners, so basically they can easily understand each and every contexted features at a very easy level depth. Okay, so now comes to the specific query of this particular thing. Just a second. Let me show you some kind of demo from an OpenAI's website. And do I have the access? And then I will be coming with our examples. And then I will be jumping into your queries. Cool. So what I was telling is all about the GPT-3 is all about a few short learners. And since it is a few short learners, so it have an easy context of each and every minute level features. So now, what does this GPT-3 is playing all about? The GPT-3, let us understand any kind of example. So you can see OpenAI's multiple example over it, right? There are X number of examples that the OpenAI had been right now created. So suppose let me see any kind of code level explanation kind of stuff. So cool. So we have so we have something called as the code to natural language. One of the example that I have told right now to you peeps. So here we have a common code written in Python, and I guess everyone can see my screen and see the code equally well. So I'm just browsing it out. Okay, so we have a general code in Python. So if you want to generate explanation about this particular code, so GPT-3 had multiple variations of the model. So the most advanced model that plays for this kind of architectures or code level automations or any kind of code automation is GPT-3 Codex. So, and for any kind of text automations or text generation is something called as the GPT-3 Text Da Vinci, right? So let us see what kind of explanation it generates. So, okay. So yes, it gave me an explanation, and let us see how much good the explanation is. So it tells, okay, my function takes 3 arguments, right? And this is a data frame, okay, and the column is named as the completion. Okay, nice. So it had told nicely what the entire code is doing. Now, many of you peeps might be thinking, so it is a pre-trained code. You have already written the code. It is doing well. So let us take any example from code forces. So I'm just copying my code, a code forces example from one of my friends. So he's one of the code forces grandmaster. So I'm just taking any of the example of code from himself. Okay. So until unless the site gets I guess. Cool. So I'm just taking any submissions of him, any XYZ, any submissions of it. So okay. So let us see. So this code is not in Python right now. Okay. So let us understand. Okay. And we have to always specify which kind of programming language we're dealing with, and let us see. Okay, I'm just not telling about completion. I have to change my prompt. Okay, so see, so sometime before someone is telling like GPT-3 is not a modified search engine, so it can tell from where I am copying the code. So this is this is the reason why it is my hypothesis. It is actually searching all over the internet. Right? It's not a real-time search, but it's all about a search from a database. Okay. So it is writing an explanation of this code. So this engine is so robust, it can generate anything out of it. So it is giving a lot of explanation. So if I tell calculate time complexity of the code above. Okay, so let us see what does the GPT-3 gives. There is a game. Okay, so it is giving a time complexity of this particular code. If you want to change this query to space complexity, it will be returning out the space complexity of that particular code as well. So this is a very quick demo about the GPT-3 engine. You guys might be curious like how to get access of these models. So you go to OpenAI and you guys can just tell whatever use cases you have. If that use cases sounds amazing, okay, someone had given a, so can you please test this code? Okay, cool. I'm just testing it out. Cool. So you want explanation or something complexity or transformation? What kind of use case you want? What kind of, just a second. What kind of use case you want? This is a Java code. Yes. So, okay, just an explanation. Cool. So you need some sort of explanation of it. So I don't know why my search is not working. Just a second. Let me search it out. I'm just typing out the code. I don't know why my search is not taking this thing from Zoom chats. Cool. So let's see what GPT-3 gives out. I will not be surprised if it is getting failed. Just you have to rewrite the query because it's taking some sort of glitches. Okay. So I guess you got your explanation. Anyone can validate it. Cool. Cool. Okay. So you're okay with the explanation. Great. So yes, so this is the power of the GPT-3, guys. So you guys can also, so you might be, I guess everyone will be of you might be excited to use it. So yes, so for the code thing, we will be soon launching, like if you want to have the feel of this kind of engines. So the open source things that you can use right now is Repellit Codex. So Repellit is a compiler. So they had already introduced GPT-3 in their coding engines. A lot of people is using it out. Even if you have GitHub student account, you can easily or if you're an open source maintainer at any repository, you can go and freely use Copilot. Another platform is called Hugging Face Transformer Bloom's model you can use. And soon in the market, we are also going to give out this kind of GPT-3 use cases from the Power of Newton School. We are using a lot of places GPT-3. So many of you might be thinking how to customize this model. So there are general two ways to customize this model. Is just a quick part, then I will be jumping into the Q&A. Okay. So if you can go directly with the documentation of an OpenAI. So the documentation of the OpenAI directly gives you an access to customize or the fine tune the GPT-3 engine. So whatever you have to do is you have to collect a heck lot of data, and you can either annotate the data or you can directly parse that data. This kind of engines have the self-annotating power as well, and simply parse the data by following the steps. So this is the most trivial way to just to do fine tuning. If you don't want to do this type of fine tuning, you want to write code for it, so what you can do is you can add some kind of additional layers by going to the code base of these GPT-3 engines, and you can write additional subsequent layers to these models so that you can modify it for your own use cases. Cool. So, okay, so this is all about the power of GPT-3, about the use cases we are doing at Newton in school, or myself, we are experimenting it out. And we are actually using this OpenAI and GPT-3 a lot to revolutionize the edtech, from interview automation to code automation to giving this kind of a pointed analysis to a coder. Hey, you are writing this wrong. You should do this in this way, so that your code should be optimal, and a lot of places. So cool. So let us jump into some kind of Q&A. Okay. So what is GPT-3 is already answered. What is a paradox? So nice question. What is a paradox? So if you had studied about paradox, if you had studied about axioms, if you had before studying the geometric theorems, so axioms are something that is called as like, okay, we had taken it granted, something like this. After a lot of observations, the same thing goes for the paradox as well. So dataset is freely available for chargeable at a month. Will it probably later? Data sets. Okay. So got your point. So it's not a data set. Like, I guess you might be asking about the GPT-3 model. So the GPT-3 models are not so much costly. It is $0.0012 per thousand token, 1,024 tokens. So this 1,024 tokens are near about to 750 words, something like this, and that is very minimal. Text Da Vinci. Okay, you can directly log in into the GPT-3 website, and you can have a 1 month of free trial as well without giving you any kind of cards. But yes, so the general architecture that this kind of OpenAI Pips is doing, it's not going to be open source in the near future as well, because this is the revolution. So if they will have a lot of revenue about it. Okay. And also the GPT-3 is not going to be also freely accessible for everyone in the industry, specifically not for the students, specifically not who are actually practicing, because these things can be used for a lot of cheatings and something like this. So already OpenAI, I had talked with some kind of fellows at OpenAI, they are already working on this kind of privacy policies. So it's, yes, it will be accessible for professionals, industrial leaders, developers, businessmen, everyone can use it. But you have to be specifically variated. How to do GPT-3 setup for a specific domain, how to put the domain's data include into the database. Okay. So, okay, this is a nice question. So, okay, so see, GPT-3 setup means, so if you have the access of the GPT-3, it might be Codex or it might be Text Da Vinci, anything, or might be a free access. So the first thing is understand what use case you want to build, and first come to playground and try with several queries. See, the major game in the GPT-3 is you have to understand which query it understands, because many queries it cannot understand. Okay, it will return you the jargon. Understand the query. So I'm just going back to the playground. There are innumerable ways to integrate GPT-3. I'm just giving you out. So I'm just taking any example for a quick. Suppose this is an example of parse and unstructured data. So suppose this particular query is fitting your need. Okay. So this OpenAI Pips have give you some kind of a API level code for this. So this is a high level API level code. So now you can directly integrate this API with your use case or your application or your website, something like this. Okay. So you can modify these individual queries with some sort of automation. So this is one way to directly integrate the OpenAI, or directly integrate it through API. This is one of the way. What is the second way to integrate to your specific domain use case is, that means I guess you are mostly wanting to fine tune the data. So another thing is you can directly go to the documentation. There are same options to hit a fine tuning API of OpenAI, and you can directly put your own data. Means like you have to collect it into any format. It might be a JSON data, it might be a CSV data, it might be a text data. So this OpenAI can convert this data onto their own end into a specific format called as JSON-L. So this thing is again, like someone had told, like Google had already achieved it. Yes, Google had already achieved it, TensorFlow. So in TensorFlow also, whatever data you play with TensorFlow at the backend, it gets converted into TF data record and then used to play. The same kind of architecture OpenAI Pips used to also do. So whatever you have to do is only collect your data and parse it to the fine tuning API, and it will be done. Last but not the least, if you are an engineer, then if you're a developer, then you can directly customize into the model according in the feature processing part, what feature you want to deal with or not. But for this, you have to be a developer or AI developer, something like this. I have GPT-3 contender with this accuracy level. So, okay, cool. So this is a very controversial question because GPT-3 is still in the experimentation level, and even it is in beta right now. But whatever I personally tell, like GPT-3 having a production level or a real time 60 to 65% of a particular accurate case, and this all these real time applications are just like a human like applications in correspondence to the human-like models that had been already developed, a model called as Bert Human or a model called as Robert Human, or some years before another model has been introduced by Microsoft called as Microsoft DBERTA, or many other companies had introduced this sort of models, but they had only catered 30 to 35% of human level accuracy. But generally, the promised accuracy as per the researchers and experimentation is 60 to 65% for GPT-3, though it is also very use case specific, for it is dependent on which use case you are using it out. Does GPT-3 use Markov chain estimation for central plot value on the entire sequence? No. It's a very nice observation. I guess you can relate with this kind of the genetic architectures of Markov chain. So it is, you can, yes, like the basic hypothesis of the Markov chain can be followed, but it is something called as the not a chain or a cyclic Markov chain. The genetic feeding happens. It basically how this genetic architecture inspiring GPT-3 is, if they learns into a feature, it always leaves a print of that feature at the backend, and on the particular based on that particular print, if any modification comes for the feature in any computation or any processing, that print will be getting modified every time. So this is a very minute chain of difference in between a cyclic Markov chain, because this print revamping is not being there on that, a feature print revamping is not being there on the Markov chain, general Markov chain architectures. But yes, the central pivot thing is being also here, but here the central pivot logic is something different. You can study that GPT-3 research paper. It will helping you out to have a corresponding analysis in between these two. Are these functionalities free or GPT subscription? Yes, GPT-3 needs a subscription. If you want to have a feel like GPT-3 for this code automation, go to Replit Codex, or you can use Hugging Face Bloom. This question is good. Can GPT-3 bypass a lot of opportunities in future? So well, this is again a very controversial question for AI, and so I will answer this question from my philosophy. AI is not made to bypass any opportunity. AI is not made to bypass any human. AI is made to make life easy. Okay. So even this code automations, everything is made for making a developer's life easy. That's it. So, but how to build on domains database? Okay. So basically what do just can you please clarify it out? Like what specifically domains database means, like what use case you want to cater, so that I can cater your answer in a very better way. Okay. So there are a lot of questions over here. I guess, can we use GPT-3 for sentiment analysis in regions, care language, Bengali, Tamil? Yes. GPT-3 and also OpenAI had launched an open model, a free to use model called as open source, model called OpenAI Whisper. OpenAI Whisper understand this all kind of languages. Even GPT-3 understand English, Bengali, Tamil, Telugu. Write the code and tell GPT-3 to paraphrase it. GPT-3 will understand it and paraphrase it. So it can. GPT-4, imagine them. Yes, GPT-3 is already going into GPT-4 after the launch of the Whisper. Whisper is the most robust speech-to-text engine. Whatever the speech-to-text is being present in the market, Facebook had already revolutionized it back by introducing their large-scale TF5 BART engine, BART. This is not BERT. So they had played a lot of ASR, and that BART is being customized by a lot of models that includes Resemble AI, Assembly AI, and XYZ. But GPT-3 had nailed it out, a single time launch with all use cases. So that is the researchers or engineers like us is already predicting GPT-4 is coming very soon. Okay, there are some other doubts. The domain is healthcare. Okay, I guess you had reached me out in LinkedIn, right? So I had replied back to your mail because I guess I had read your query, and I guess it needs a lot of discussion out of this session. So I had mailed you out that, so let's book a time and we can chat it accordingly, right? So because since it is a complete domain specific, so it's completely a use case specific. Any one of you can connect with me on my LinkedIn, and I will be happy to answer your queries out. And also let me know, keep on posting, keep me tagging about what amazing experimentations you guys are doing with GPT-3. For George, yes. I guess I had written the answer to you like to my today evening just before this session because I got busy last 2 weeks a lot. I missed your mail. So just let me know if you can see it. Otherwise, I am re-triggering you an email on the LinkedIn. Okay.
Yeah, so thanks a lot, Anustup.
Yeah. Thank you so much.
Yeah, so on the behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. I am sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.
Sure. Thank you so much, guys. Thank you so much. Have a nice day.
Thank you so much.